Hello, so this is the last metapopulation lecture until we get into meta-communities. Now, the classic metapopulation model has, it's represented right here, right? What it has are identical patches that are either, have the species or don't have the species. Now, each patch is identical, and that's different from a mainland island. Now, a mainland island type of metapopulation. Now, there's certain mathematical properties that I don't necessarily really want to get into. I don't think are useful for this class, but essentially what we have here is a mainland, whether this is a continent or a big island or something, where essentially you just never get extinction. So you can have a flow of species out from the mainland to these other patches that essentially have these patches then follow the metapopulation models, as opposed to the mainland, which is just always having the population there. Now, another mathematical model has to do with a Patchy population. This is essentially just one big area where, here's the area, but in that area you have specific patches or specific populations that aren't necessarily like islands, or there's free movement between, basically easily, movement between these, because there isn't like habitat patches themselves. The whole big thing is the habitat patch, but then you have small areas where there's like clumps of organisms, and that is where you get the subpopulations here. So it's basically like a metapopulation model with really high rates of migration in between the different areas. Then there's non-equilibrium metapopulations, and non-equilibrium metapopulations have an imbalance between extinction and colonization. So extinction can happen rapidly, and if you have an isolating event, or if a population gets isolated from migration, what will oftentimes happen is that extinction will, completely kill off that population more rapidly. So it's not as stable as what we would think of as the classic Levin's type of population. Then there's all sorts of like intermediate cases where you could like have a Patchy population with and islands around it, where you could have the mainland be equivalent to this and then the islands be out here, but this itself is a Patchy population. The mainland itself is a Patchy population. You can mix and match these type of things, and the maths make it different, but there's some interesting consequences when we're thinking about conservation for this. Before I want to talk about those, I want to talk about source and sink dynamics. Now, if we think about different patches, we know that patches are different. And we can kind of categorize these patches into sources and sinks. Now, a source is a high-quality habitat where the population is unlikely to go to extinct. Think about it in this previous model as kind of right here. So we'd have a source as the mainland in this case. And what often happens then is, because births are more than deaths, there's those births, those organisms have to go somewhere, and they're oftentimes exported to other habitats, and potentially other habitats that are at lower quality. And that's what a sink habitat is. And now a sink habitat is a low quality habitat that is essentially deaths are higher than births. So maybe I should write that in here, where you do have more deaths than births. So this is an inherently unstable system, right? You'd expect you can't have a stable population if deaths are more. So in a sink population, basically what you have is a flow of individuals from the source to the sink, such that the sink population is maintained only because of that flow from the source. So when we think about conservation and these kind of like source-sink dynamics, and determining the metapopulation type is really, really important. So if you have a population that acts like the classic Levin's metapopulation, what you're gonna have, what's most important to keep a stable population is the number of patches. That's what's most important. The more patches you have, the higher the population can be, and the lower probability that all of those patches will go extinct at the same time. On a mainland island type of metapopulation, what you really need to do is, if these islands are in fact sinks, or at least not necessarily super great sources, the mainland is most important. Okay, those sources, those source habitats are going to be the most important thing to keep around. Sink habitats, are essentially functionally not doing anything, right? If they're just literally losing species all the time or losing individuals all the time, they're not necessarily helping the species expand anywhere. But identifying those source habitats, those high quality habitat patches, that's really important. With a patchy metapopulation, what you would expect is it's not necessarily like these individual patches, but increasing the area of the reserve. The more area you have in that reserve, the more populations that you can have. And it's essentially thinking about it like the classic Levins, where it's the number of patches here. Now, how do you get number of patches in a patchy population? Is increasing the area, because then you can potentially have more patches around here. If your system and the organism that you're trying to conserve, or the ecosystems that you're trying to conserve, is in a non-equilibrium state, then what matters is preventing isolation, right? Because we know that extinction can sometimes be really, really key here for because it's not balanced by colonization. So if you ever cut off the migration routes between different patches, that is going to be a big problem, because they'll oftentimes then, if the way metapopulations are modeled to work is that they will occasionally go extinct. And if you then have no forms of migration to go from the other patches, over back to what this now empty patch, that isolation will potentially really, really have the patch go extinct quite quickly. Okay, that was just a little cleanup thinking about metapopulations and conservation, and with that, I'll see you later, and we'll get talking about metacommunities here next.